All right, so this is an extra support video on integrating arcsine and arctangent. So I'm going to do some examples in terms of that. All right, so I'm going to start with the most basic example. That's a 1 by any means. So when I look at this, I see a fraction, square root, and there's a constant subtracting something. And that's my template to understand its arcsine. So first I want to recognize what a is. A is the constant in front, and it's the square root of that number, and the square root of 1 is 1. U is the square root of x squared, that's x. And then what's the derivative of what you just did? The derivative of x is 1, and that's going to be the numerator. So in general, when you integrate, what you're looking at is the square root of some constant squared minus something else squared. I call this u. So think of this as a, u, and u prime. That's what we're looking at. So take the constant to find what a is, square root it. Take what's being subtracted, and then take the square root of that, and then take the derivative, and that's the numerator. So that's what I'm looking at right now. So up here then, once you have this information, now what do you do with it? So for arcsine, you simply write arcsine, and then inside is going to be the fraction, and it's going to be u over a. So u is x, a is 1, so that's x over 1 or just x, and then don't forget the cookie. So in this situation, you would write arcsine u over a, and then plus c. Okay, so let's practice a few of just arcsine. All right, so what do I see here? So you can write it down. I want to know how to integrate this and why it's arcsine. So it's a fraction, square root, and it's a constant subtract something else. That's what I'm looking at. And so to do that, I'm going to write down what a equals. This is a way to organize it. A is this number, the constant, but it's the square root of it. So it's the square root of 4, which is 2. U is what it's subtracting, so it's the square root of x to the 4th, which is x squared. And then u prime is the derivative of that, which is 2x. So when I come back over here, I'm going to write it with the correct hook. And the correct hook is 2x. Now, what was it before? 4. What did it become? 2. So 4 divided by 2 is going to be in front of our answer. Now, we're ready to answer it. So 4 divided by 2 is 2. That's going to be in front. Arcsine. And then what goes inside is u over a. So in this case, it's x squared over 2. There it is. Plus c. Are we going to do another one? Is that okay? So let's try another one. So we're going to integrate. And it's the square root. My daughter's coming in here right now. So the square root of, yes.
Can you check my math work?
Yes, I can check your math work. So, why didn't you? So 32, 33. You need to number 2. You need to do over again, and then number 3 is good. So can you do number 2 over again for me?
No. Okay, fine.
All right, thank you. And then I'll check it once you're done. Number 2 over again.
How many jumps are these? What jumps are
for number 2? So for number 2, we just didn't jump quite correctly.
But this one?
Well, I think, well, here, if you look at the jumps, you jumped okay, and then what maybe I don't know what this number is because you wrote it kind of.
33.
So do you think 20 and 3 more is that number?
No, I think it's 23.
That's the right answer.
Hey, you didn't pen.
Good job. All right, let me continue this one.
Wait, is all the other ones right?
Yes, all the other ones are perfect.
I think.
All right, enough. Thank you. I'll be out there in a second. All right, that was fun, right? So, can you integrate that? So I'm going to press pause, and I want you to try it, and then press play, and then we're going to do it. So I recognize the form is arcsine. So for A, it's the square root of 16, which is 4. For U, it's the square root of 9x squared, which is 3x. And then U prime is the square root of 3, is 3. Then, for us to do this, I'm going to write it properly, the way I need the numerator to be. So I'm going to rewrite 16 minus 9x squared. And what I want is a 3, not a 5. And then what fraction do I write down? So what was it before over what it became? And then that number is going to be in front. So our answer is 5/3 arcsine. Inside is going to be u over a. So that means 3x over 4, and then the cookie. I don't know. Is that enough, you think? So you get the sense of it. So arctangent, can we look at that one? Here, let me do one more like this. So I'll do one more. All right, write that one down. Here's one more arcsine, then we'll look at arctangent. So if you look at this, press pause and try it, and then press play. So in this example, a is the square root of the constant, and the square root of 3 is the square root of 3. U is the square root of x subtract 2 squared. Now note the square root and the square cross out, so all you're left with then is x minus 2. And the derivative of that, of x subtract 2, is just 1. So we're going to write it properly. The hook we want is 1. Everything else we're going to rewrite. Then, when I look at this, I need to understand what was it before and what did it become. So 7 over 1, or just 7, now it's set up correctly. So now the answer starts with 7, arcsine, and then it's u over a, which is x minus 2 over root 3 plus c, and you've integrated it. All right, next one, arctangent. Now, what does arctangent look differently than what we just did? All right, so let's see how it looks differently. Oh, let me give you a nicer. That's fine. Okay, so what do I notice differently here? So first of all, no square root in the denominator, and it's not subtracting, it's adding. So right away, I see a difference in terms of that. So we're going to start the same way. We're going to start with a. A is the square root of 4, which is 2. U, which is the square root of 3x squared, which is root 3x. And then u prime, which is root 3. Then the format is arctangent. So here's the general look of it. A squared plus u squared, and then u prime du. That's what it looks like, what we're looking at. And then it's going to be 1 over a arctan, and then it's u over a plus c. So that's the format we're looking at. So we start with a fraction. Well, actually, first we need to start with the correct hook. So the correct hook, root 3. And what was it before, and what did it become? So it's 4 over root 3 is going to be the fraction in front. So we're going to start there, 4 over root 3 times, and then there's a fraction. It's 1 over a. So that's 1 over 2. Then we write down arctangent, and then inside would be u over a, which is x over 2. And then the cookie. All right, let's try this again. All right, write this down, And then if you're confident, press pause and try it. If not, you can work with me. All right, here we go. So in this example, a equals the square root of 9, which is 3. U is the square root of ex, which is all squared, so the square and the square root undo each other. This could also be written as e to the 2x, and it would be the same thing. When you take the square root, it's just e to the x, and that means the derivative of e to the x is still e to the x. So I'm going to write it properly. So all I want is e to the x. Everything else can stay the same. What was it before and what did it become? So 2 divided by 1, or just 2 in front. And now, how do you write the answer? So you start with 2, and then for arctangent, it's 1 over a. So that's 1 over 3. Then arctan, and then u over a. And then plus the cookie. Done. All right, let's try it a couple more like that. All right, let's see if you can integrate this. So press pause and try. All right, here we go. A, it's the square root of 7. Did you get that? U, it's just x subtract 4. Yes? And then u prime would be 1. Good job. Next, we're going to write it properly. So we need a 1 in the numerator. Now, what was it before over what it became? So that's a 3. So our answer then is going to start with 3 times. Now for arctangent, it starts with a fraction, which is 1 over a, which is root 7. You don't need to rationalize it. Then it's arctan, and then it's u over a. So x subtract 4 over root 7, and then don't forget the candy. Now, there are situations where you need to complete the square, and this is where it might be getting confusing. So what would that look like if you had to complete the square? So let's say you had something that looked like this, and you're asked to integrate it. Normally, you would see a trinomial. It may not even be factorable in the denominator. So in this case, I need to set it up so it's in the form of arctangent to be able to integrate. And then to do this, I need to complete the square. So to complete the square, I need to understand what number represents b in this trinomial. So a, b, c. So b is equal to 6. And to complete the square, I divide it by 2 and square it. So 3 squared is 9. And then I'm going to rewrite this. So that 9 I need. I'm going to add 9 and put parentheses around it. That's going to be a perfect square. But if I add 9, I also need to subtract 9. And there it is, subtracting 9. Then I'm going to combine like terms, so and factor. So x squared plus 6x plus 9, if you factor it, that's 3 and 3. So 3 times 3 is 9, 3 plus 3 is 6. It's x plus 3 squared if you factored it. Then negative 10 and negative 9 is negative 19. And now it's in the form where you can integrate it. So a is equal to this, it should have been a plus, right? Why didn't I have that? So can I change it quick? So let's say I didn't make a mistake and I made this a plus 10, because if it's not adding, then we're going to be in trouble. So plus 10, subtract 9, which would make this just plus 1. Is that okay? I'm making up these questions as I go along. So plus 1. Hey, that's way better. Otherwise, if it's subtracting, it's not arctangent. But plus, I can. So a is equal to the square root of 1, which is 1. U is the square root, and the square, they undo each other and leave you with x plus 3. And then the derivative of that is 1. So I'm going to rewrite this properly with the correct hook in the numerator, which is 1. And what was it before over what it became? I need a 5 in front. So my answer is going to start with 5 times a fraction. And it's going to be 1 over a. In this case, a is 1, so 1 over 1, which won't change anything, but it's good to know the form. And then u over a, which is x plus 3 over 1, or just x plus 3, and then plus the cookie. Let's try it again. I'll try not to make the same mistake again. You never know. So let's try it. So I think I did okay this time. I want to recognize that I have a trinomial in the denominator. And there's not many techniques I can use with that trinomial that would help me. So it's a good indicator that could well be arctangent. I might need to complete the square. So recognize what b is, which is 8. And then what two things do you do to complete the square? Divide by 2 and square. So that number is 16. Then when I integrate this, oh wait a second. Then when I set this up, that number 16, I'm going to add 16, put parentheses around it. Then I'm also going to subtract 16. Oh, silly me. I made the same mistake again. So I'm going to add 17. Silly me. Next time, maybe I'll do it one more time and give myself one more chance. Subtract 16. That has to be a positive number when I combine these together. That was continually being my mistake. Can you factor this? What two numbers multiply to 16 and add to 8? That's x plus 4 squared. And then, of course, you end up with 17 take away positive 1, and that has to be adding for it to be arctangent. A then would equal the square root of 1. U would be the square root and square. They undo each other, so this is x plus 4, and then u prime would be 1. So to set this up correctly, I'll need a 3 in front, and then a 1 left behind. So I wanted it to be 1, so 3 divided by 1 gives me that 3 in front, and now I'm ready. So I start with the 3. The fraction would be 1 over a. 1 over 1 is just still 1. And then arctan, and then u over a. X plus 4 over 1, and then plus the kogi. All right, one more chance for me, and then I'm done. So can you complete the square here? So let's try it again. One more time. All right, I think I feel okay about this one. I think I've learned from my mistakes, but you just never know. So, can you write this down, press pause, and try to complete the square in order to do this? All right, so in this situation with the trinomial in the denominator, I'm going to take 10 divided by 2 and square it. So that number is 25. So I'm going to rewrite this and add 25 to complete the square. And I'm going to subtract 25 so it stays the same fraction. So I add and subtract 25. Now, the first parentheses is a perfect square. So what are the two numbers there? That's positive 5 and positive 5. So we square it. 4 take away 25 is 9. So yay, finally, I did it correctly. And then I understand a is the square root of 9. U is the square root and square, so this is x plus 5. And then u prime is 1. So we want a 1. So what it was before over what it became, I need a 4 in front. I don't know if I have enough room here. I'm going to do it. 4 is going to start with our answer times 1 over a. This time a is 3, so we need a 1/3. Then arctangent, and then u over a. So x plus 5 over 1, or just x plus 5, and then the cookie. And it's done! Anyways, I hope that helped. A little extra practice. Anything else you want, just ask me. Maybe we can get a video on it. All right, Mr. G Math, over and out.